All right, guys, today we are going to start talking about simple probability. The first thing that we are going to look at is some vocabulary. Now, the checklist for the next couple weeks is simple probability, making predictions, area of triangles, circumference, and area of circles. Please do not forget that all of your lessons need to be completed successfully by June 30th. All right, so really the only vocabulary word that we're going to talk about today is probability. So this is the likelihood that something is going to take place. And if you think about it, you think about chances of rain. So if there's 0% chance of rain, it's not going to rain. There's a 100% chance of rain, then it's definitely going to rain. 50%, maybe it will, maybe it won't. 75%, it probably will. More than likely, it will rain. Whereas if it's 25%, less likely that it's going to rain. And when we find probability, we set it up as a ratio. And we can express this ratio as a fraction. And we express it as the number of favorable outcomes, or like what we want to happen, out of the total number of possible outcomes. So here we see a number line, and we can actually express probability in a couple different ways. We can express it as a decimal, a percent, or a fraction. So if something is impossible, that is a 0% chance that it happens, or 0 out of 1. Now, all the way on the other end of the number line, if something is certain, that would be 100% chance of it happening, which is equivalent to 1 whole, or 1 out of 1. An even chance, which is halfway in the middle, that's our 50%. 50%. So it's equally likely of happening, which we can represent as 1/2 or 0.5. Now, unlikely, we're going to say that's halfway in between 0 and 50%. So let's say 25%. So less likely, which is 1 out of 4 or 0.25. Well, when we come over to likely, which is halfway in between 50 and 100, that's our 75% chance, or 3 out of 4, or 0.75. Now, in this lesson, we will be working between fractions, decimals, and percents. So if you are struggling with that, please come to office hours. Some more vocabulary that we're going to look at is experimental probability. So this is what actually happens in an experiment, whereas theoretical probability is what should happen in an experiment. Now, what should happen and what does happen is not always the same, so there is a difference between these two words. And sample space is all of the possible outcomes of an event, and we can represent that in a couple different ways. We can represent it as a list, a tree diagram, which kind of looks like a tree, or a table. So the first thing that we're going to look at is we want to find the probability of landing on a yellow. So our yellow, this is our desired event. So I'm going to write a probability statement. So we will write P, capital P, then we'll put a parentheses, and we want yellow. So this is our desired event right here. Now I'm going to set up my fraction, my ratio. Well, if I'm desiring a yellow, I see that there's only 2 yellows. So there's 2 out of the total of 8 that would be yellow. Well, I see I can simplify 2 eighths, and that is equivalent to 1 out of 4. So then we'll come look at landing on an even number. So again, I want to write my statement, which is probability of even. And when I count, I see 2 is even, 8 is even, 6 is even, and 4 is even. So that is 4 out of all 8. So that is 1/2, or 50%, or 0.5. Now last, we want to look at not landing on a red. So I will be happy with anything that is not a red. So probability of not red. Well, that's not red, not red, and not red. So I have 7 out of 8, which I know I cannot simplify. So now we're rolling a 6-sided die. We want to know the theoretical, so this is what should happen, probability of rolling an odd number. So I'm going to actually list out my sample space, which is all of the possibilities. I can roll a 1, a 2, a 3, a 4, a 5, and a 6. So probability of rolling an odd, that is 3 out of all 6 possibilities, which simplifies to 1/2. Now we want the probability of just rolling a 3. Well, this is the only 3 I see. So that's 1 out of all 6. I cannot simplify that. Now we want to know the experimental probability. So this is what did happen. What did happen? And notice we're now given a frequency table with all the numbers on the 6-sided die and how often they were rolled. So I see that 1 was rolled 3 times, 2 was rolled 4 times, 3 was rolled 6, 4 was rolled 5, 5 was rolled 7 times, and 6 was rolled 5, which means altogether we rolled a total of 30 times. So we rolled 30 total times. And this is important because we'll need to know the total amount when we write our ratios for probability. So we want the probability of rolling an odd. Well, 1 is odd, 3 is odd, and 5 is odd. So when I look at the frequency that we rolled odds, I see that we rolled them 16 times out of the 30 total, which I can simplify to 8/15. When we look at rolling a 3, I see that we only rolled a 3 6 times. So probability of rolling that 3 was 6 out of 30, which I can simplify to an equivalent ratio of 1/5. So now we're looking at a table, and we're given a guy, he's playing baseball, and he's at bat, and he's either getting an out or a hit. So we want to know the probability of getting a hit, which was, 2 out of the 6 attempts, which simplifies to our 1/3, or 33 1/3%, or 0.3 repeating. And now our probability of getting an out or not getting a hit, same thing. We had 1, 2, 3, and 4. 4 out of 6, which simplifies to 2 out of 3. And I want us to take a look at a moment and see the probability of getting a hit and the probability of getting an out or not getting a hit. When you add them up, they add to 1 whole. Because this is the probability of an event happening plus the probability of the event not happening. And it should always equal 1. And if we think about that logically, if there is a 20% chance of rain, that means that there's an 80% chance that it does not rain. And when you add those together, you do still get 100%, which we still know is 1 whole. So anytime you have an event and you add the probability of an event happening plus an event not happening, you will always get a sum of 1. So now we have some marbles in a jar. We have 6 red, we have 7 blue, 3 orange, 2 pink, and 2 purple. We want the probability of choosing a red. So probability of choosing a red, well, when I look, I see that I was given 6 red. So that is 6 out of, and I need to see how many total I have. So I have 6, 7, 3, 2, and 2. Well, I see that this is going to give me a sum of 20. So I have 6 out of 20. And that's going to equal, because I can simplify this, 3 out of 10, or 30%, or 0.3, 3/10. Now this next one, it's not necessarily numerical, but we want to know what's most likely to pull. Well, if I have 6 red, 7 blue, 3 orange, 2 pink, and 2 purple, I'm more likely to select blue because there are more blue marbles in the jar. I would be equally likely to select pink or purple because those have the same amount. Red would be more likely than pink because there were more red than pink. So big word problem. So we are looking at this word problem and we need to identify some important information. So as I read through this the first time, I'm gonna just kind of think about what's happening. So we are working at a game booth at our school fair. To play the game, you toss quarters onto the table that has squares and circles on it. If a quarter lands completely in a circle, the player wins $1. You start to count the numbers of wins and losses. So far, there are 17 wins and 123 losses. What is the experimental probability that a person will win? So as I read this, I kind of see we're talking about a game and we're talking about wins and we have losses. The problem is asking us to find what the experimental probability of a person winning is. So we want the probability of winning. Well, I know experimental means what does happen. So the problem told us what already did happen is we had 17 wins and we had 123 losses. Well, that means altogether we had 140 games played, total games. And remember, our total is important with probability because when we set up our ratio, we always do the desired outcomes out of the total possible outcomes. So the probability of winning, well, that was 17 out of the 140. 17 out of 140. That is a small probability of winning. And that is our last example of probability. Guys, as you work through these problems, please remember converting between fractions, decimals, and percents, and always look at the fraction to see if they simplified it in their answer.